Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course, General Organic Chemistry. So today we begin with lecture 12 from the course, but make sure you watch the previous ones before viewing this one. So in the last lecture, we were discussing the nomenclature of the functional groups, wherein we have already discussed about the alkyl halides, the alcohols and the ethers. So moving on further, we will be learning a few more functional groups, that is going to be aldehydes and ketones, carboxylic acids, derivatives of carboxylic acids, which is also going to include the very important derivative that is going to be esters. So we will begin first of all with the aldehydes. So aldehydes or alkanals are the first compounds that we learn. So aldehydes are going to be the common names. The alkanals are going to be the IUPAC name. And these are the compounds which are obtained by replacing two hydrogen atoms of an alkane. And these two hydrogen atoms, they are attached to the terminal carbon atom of the alkane by divalent oxygen atom. So let us understand this definition with the general formula of the compound. And one thing I would like to tell you over here is that you are not supposed to mug up these definitions. Nobody is going to ask you them. These are just for your understanding because we are just building up our concepts. The concepts, they should be very clear. So we are putting in the definitions so that you have a thorough understanding what is happening in these various compounds, what is the difference in all of them. So the general formula for the compound is CnH2n plus 1 CHO. Okay, so had this been an alkane, instead of this oxygen, there would have been two hydrogen atoms, right? So it would have become CnH2n plus 1 CH3. So that would have been an alkane. Right now, what we have done, we have removed two hydrogens and replaced this by a oxygen, and carbon oxygen we have a double bond. Okay, and the general formula, this can also be represented by RCHO, and this is R is going to be an alkyl group, right? So I hope this is clear to you people. One thing was over here was that the carbon is going to be a terminal carbon. Okay, so what is a terminal carbon? When you have a long chain of carbon, the last and the first carbon, whatever way you started with, the first and the last carbon, they are going to be the terminal carbons, and it is that this terminal carbon that we will be having this CHO group. Okay, so this is very important. It is not going to be anywhere on the non-terminal carbons or the carbon atoms which are present in between the chain. Okay, so these aldehydes, they are obtained by replacing two hydrogen atoms of an alkane attached to the terminal carbon atom by the divalent oxygen atom. The functional group for the compound, I hope you can now understand, this is going to be the CHO group. And when we talk about this CO, this group is called as a carbonyl group. Okay, so you will be seeing this carbonyl group even in ketones also. So this, please do remember, this is called as a carbonyl group, CARBONYL. Now the suffix we are going to use for these is going to be a al, and this is a secondary suffix. The primary suffix, I hope you all know, that is going to be telling us the nature of the carbon-carbon bonds. Either it is a single bond, a double bond, or a triple bond. So the IUPAC names, how are we going to obtain them from? So we are going to write the IUPAC names by replacing the E of the corresponding alkane by a al. So let us see a few examples which will help you understand better. So when I say now the value of N for the aldehyde, so here I have written the value of N to be 0. So here please do not confuse it with your previous compounds. Here N0 is standing for the alkyl group. There is one carbon which is already present in this CHO group, and the N we are talking about here is N standing for the alkyl group. Okay, so when N is going to be 0, this means that in the alkyl group which is attached to the functional group CHO, the number of carbon atoms is 0, and when that is going to be 0, what we will be having is only H. So the compound is going to become CHO HCHO. The IUPAC name is going to be from the corresponding alkane. So in the alkane, which is going to have one carbon atom, what is the name of that alkane? It is going to be methane. So methane, now remove the E and write a al. So we get methanol. Okay, so just do not confuse over here. N0 we are denoting here for the alkyl group, but when we are talking about the number of carbon atoms for the IUPAC name, we are going to include this carbon as well. Okay, so this is carbon number 1 only, so this is methanol from the corresponding alkane methane. I will be just talking about the common names just a moment later. Next we have N equal to 1. So this is the alkyl group which is having one carbon. So this becomes CH3CHO, and because now the compound has two carbons, so this is going to be named as ethanol. So similarly, when N is going to be 2, the alkyl group is having two carbons, but the molecule is having three carbons. So this is propanol, and the next is going to be butanol. Fine, I hope this is clear. The next we have is the common names. So the common names you have to remember, as I've been telling you very frequently, that whatever common names I am telling you, please do remember them as well. So it is going to be formaldehyde, acetaldehyde, propion aldehyde, and N-butyraldehyde. So these are going to be the common names for the methanol, ethanol, propanol, and butanol. So the next class of compounds, they are the ketones or the alkanones. And now you will be able to understand the definition also very well, because these are the compounds which are very much similar to the aldehydes. Ketones, they are obtained by replacing two hydrogen atoms of an alkane by a divalent oxygen atom, but this time we will not be removing the hydrogen atoms from the terminal carbon. They will be from the non-terminal carbon atom. So what are going to be the non-terminal carbons? Now neither the first carbon nor the last carbon of the chain. We will be choosing that carbon which is in between the first and the last carbon, right? So those carbons, they are called as the non-terminal carbons. So let us see the general formula. So it is going to be CnH2n plus 1, C double bonded to O, CmH2m plus 1. So CnH2n1 becomes a alkyl group, CmH2m plus 1 becomes the other alkyl group, and now these two alkyl groups, they may not be the same. Okay, and this is the functional group CO, which is present over here, which we call as the carbonyl group. This is the functional group which is present in the aldehydes also. The only difference is that in case of the aldehydes, instead of these two alkyl groups, one has to be a hydrogen. So for aldehydes, it was RCHO, and now we have RCOR dash. Okay, so I hope this is clear. So what is the functional group? It is going to be the carbonyl group C double bonded to O. So the suffix for these compounds is going to be on, and how are we going to write the names? Well, the IUPAC names, they are going to be obtained by replacing the E of the corresponding alkane by a on. And also we will be using now prefixes like 2, 3 to indicate the position of the carbon atom with the functional group, and always we will be assigning the lowest possible number to the functional group, right? So let us see a few examples. So here again the value of N is for the N or M is for the alkyl groups. So when N is equal to 1, M is equal to 1, this means that the alkyl groups, they are going to be the CH3 groups. So CH3, CO, CH3. But when you're going to write the IUPAC name, you are going to count the total number of carbons in the molecule. So this becomes 1, 2, and 3. So the alkane would have been propane. Now the ketone is going to be propanone. Propane, remove the E and put a on instead of that. Propanone. Okay. The next compound is when N is 1, so this is CH3. When M is 2, that means it is C2H5. So again, if you count the total number of carbons for the molecule, it is going to be 4 carbons. So this becomes butanone. Next we have is N2 and M2. So here what are we going to see is that we have a C2H5, CO, C2H5, and it is going to be a 5 carbon compound where the functional group is present on position number 3. So this becomes pentane 3-one. And next we have is N3 and M1. So this is going to be this over here as the carbon alkyl propyl group, and next we have is the CO, the functional group, carbonyl group, and then the CH3 corresponding to M equal to 1. Again the number of carbon atoms is going to be 5, but here now the only difference from the above is going to be the position of the functional group. Here the position of the functional group is going to be position number 2, and because you will be starting from this side, you will not be starting from this side, because here it would be position number 4 for the compound. Okay, so this is going to be pentane 2-one. So now I hope the number of the functional groups you can assign very well. You all know that very well. So now coming up to the common names. So when you're going to write the common names, you will be writing what all the alkyl groups they are present and put behind that a ketone. Okay, so for example, we have a methyl group here, a methyl group here. So this becomes dimethyl ketone, right? And next we have is a methyl group here, a ethyl group here. Arrange them alphabetically, you will be getting as ethyl methyl ketone. Next we have is a ethyl and a ethyl. So again this becomes diethyl ketone, and here it is going to be a methyl and a propyl ketone. Okay, so this is going to be arranged again in the alphabetical order. One common name for this propanone is going to be acetone. Okay, so please do remember the common name for this compound is going to be acetone. One thing that you have to remember over here when you are going to differentiate between acetaldehyde and acetone. Acetaldehyde is a 2 carbon molecule, whereas acetone is a 3 carbon molecule. So please do remember the difference over here. When we talk about acetaldehyde, it is going to be CH3CHO. It is a 2 carbon molecule, and here acetone, this is a 3 carbon molecule. Okay, so this is a difference. Children do make a mistake, so please do remember this very well. The next class of compounds are called as the carboxylic acids or the alkanoic acids. And how do we get them? Well, one carboxylic acid group, that is COOH group, if this is attached either to a hydrogen atom or an alkyl group, we call this as a carboxylic acid. And because it is just one carboxylic acid group present, so we also call this as a monocarboxylic acid. Had there been more than one COH groups present, we would have called it as a di, tri, etc. carboxylic acid, right? So the general formula for these monocarboxylic acids are going to be CnH2n plus 1 COOH, or in short as RCOOH. The next is the functional group. So now you know that the functional group is going to be COOH. So here we have a carbon double bonded to an oxygen atom, and the second side of the valency we are going to have this as a OH group present, right? So it is carbon's covalency being completed by one H or a alkyl group that would be present over here, then a oxygen which is going to be double bonded to the carbon, and a OH group which is attached to the carbon. So this makes it the 4 valencies for carbon. So the functional group is going to be COOH. The secondary suffix we will be using for these compounds is going to be oic acid, and the names, IUPAC names, we will be obtaining them by replacing E of the corresponding alkane by oic acid. So a few examples. N is going to be first of all 0, and this N means for the alkyl group again. Okay, so here we have N0, so this means that there is going to be no carbon in that. So this means a HCOOH. So this is going to be the simplest monocarboxylic acid, and we will be calling it as methanoic acid because in the compound still a carbon is present. So we have methanoic acid. The common name is called as formic acid. N N equal to 1, it is going to become CH3COH, and the IUPAC name methanoic acid, common name acetic acid. N equal to 2, it becomes ethyl group as the R group. So it is going to be CH3CH2COH, propanoic acid and propionic acid. N3 is going to be CH3CH2CH2COH, butanoic acid and N-butyric acid. The next class of compounds that we learned today are the acid derivatives, and as the name suggests, these are going to be derived from the acids. We are going to obtain them from the carboxylic acid. How? Let us understand. We will be obtaining them by replacing the hydrogen atom or the OH part of the COH group in the carboxylic acid by a suitable atom or group. So what I mean over here is that we have the general formula for the carboxylic acids to be R, C, double bonded to one oxygen atom and a single bond to the OH group, so which we call as the hydroxyl group, right? So we have this compound as the carboxylic acid. If we remove a hydrogen or we remove both of these and replace it by a suitable atom or group of atoms, we will be calling those compounds as the acid derivatives. I hope this is clear. We will be obtaining them by replacing hydrogen atom or the OH part of the COH group by an atom or a group of atoms. So let us see these acid derivatives one by one. The first acid derivative we have is the acid chlorides or the alkanoyl chlorides. So these we are going to obtain by replacing the OH part of the COH group by the chlorine atom. So the general formula of these compounds is going to be CnH2n plus 1 COCl. So we had a COOH group. We have removed the OH and replaced it by a chlorine atom. The short form you can this also write as RCOCl, and here the RCO group is going to be called as the acyl radical. Okay, so do remember this as well. And the functional group that is going to be present is going to be COCl or the COCl written in this manner. You can write it either way, it is not going to make a difference. And the suffix we will be using is going to be oil chloride. So let us see a few examples. So when we will be writing the IUPAC names, we will be replacing the oic acid of the carboxylic acid by the corresponding oil chloride. Okay, so what we have is that when N is 0, the acid we got was methanoic acid, right? So now from the methanoic acid, we have removed the OH group and replaced it by a Cl atom. So it is going to be what? It is going to be methanoyl chloride. And the common name, it was formic acid. So now this becomes formyl chloride. The next was when N was 1. So the acid we had was CH3COOH. Removed the OH, replaced it by a chlorine atom. What we are getting is ethanoyl chloride, and the common name acetyl chloride. And when N is 2, again this is for the alkyl group. I hope you will remember, because in the compound itself there is going to be one carbon atom more. So we have CH3CH2COCl, which we call as the propanoyl chloride, and as the common name it is going to be propionol chloride. The next acid derivatives we have are the acid amides or the alkanamides. Okay, so these are again going to be very easy for you to understand. We will be just simply replacing the OH part of the COH group by the NH2 group. So all you have to learn is in this acid derivatives is what is the part of the COH group you are replacing and by what group. And in fact, the whole of the nomenclature is going to be really very easy for you. It may be sounding very difficult that you have to learn so many names, you have to learn so many class of compounds, so many functional groups. But well, all of this is going to be actually very easy when you are going to learn the whole of organic chemistry again and again. These names will be coming. And it is just like that when you entered into a class and you did not know any of your friends, right? So you did not even know the name of the classmates. But then when you started sitting with those people, you started talking with them and you started knowing them, that you knew all the name of all your classmates. And then after all the names, even you came to know what their parents are doing and what their likes are, what they like eating and what they like in movies and so many other things. So it is going to be just like that with the organic compounds as well. We will be learning the names now. They may be sounding difficult now, but by the end of class 11th and 12th, you are going to find that that was the simplest thing in organic chemistry that you had to do. So we have the acid amides or the alkanamides, where we are replacing the OH part of the COH group by the NH2 group. So here the general formula for the compounds is going to be CnH2n plus 1 CONH2, or it is going to be RCONH2 group. Again, the RCO group is called as the acyl radical. So the functional group is going to be CONH2. And the suffix we will be using is called as the amide. So what we will be doing in the IUPAC name is that we will be replacing the oic acid of the corresponding carboxylic acid by the amide. So again, a few names for you people. So when N is going to be 0, we will be having the compound as HCONH2, and this is going to be methanamide and formamide. Next we have is N equal to 1 CH3CONH2. So this becomes ethanamide, the common name being acetamide. And when N is 2, it is going to be CH3CH2CONH2, proponamide and propionamide. Right? So I hope now these names, they will be sounding very easy for you people, not anything difficult, because we are just repeating those things again and again. So the next we have is the esters, a very important class of compounds, also called as the alkyl alkanoids according to the IUPAC nomenclature. So we will be obtaining them by replacing the hydrogen part now of the COH group by a alkyl group. Okay, so what are we going to do? We are going to remove this hydrogen now and replace it by a alkyl group. So what is going to be the general formula? CnH2n plus 1 COOCmH2m plus 1. Right? So we had the COO group in the center, a alkyl group this side and a alkyl group on the other side as well. You have seen something similar earlier also while we were talking about the ethers. And in the ethers, what we had was, we had an oxygen, and on either side of the oxygen we had alkyl groups. Now we have a COO group. On either side of the COO group, we are having the alkyl groups, and then we call them as the esters. And this N and M, again, they may not be equal. So the functional group is going to be the COO group. The suffix we will be using is going to be O8. Now, learning the name of these compounds, the IUPAC names, is going to be very important, because generally the students do commit a mistake while writing these names. Okay, so please understand this very well. We will be having two parts of the name. As you can see over here, it is going to be alkyl alkanoid. So one group of these two alkyl groups, we will be calling it as the alkyl group, and the other is going to be a part of the alkanoid. So let us understand this. The first word of the name of the ester is the alkyl group which is attached to oxygen. So can you see in this which is the alkyl group which is attached to oxygen? Well, it is this alkyl group which is attached to the oxygen atom. So when we write the name of the compound, for example, if I had a CH3 over here, okay, so if I write this CH3, C, this is going to be a double bond oxygen over here, a oxygen over here, and then I write a CH3 over here, right? So it is by this alkyl group which is attached to oxygen. This alkyl group is attached to the carbon, right? So what you will be doing in the name of the compound is that the first word of the name of the ester is going to be the alkyl group which is attached to the oxygen. So if we have a methyl group attached to oxygen, so this is going to be this part, right? So the CmH2m plus 1 is attached to oxygen. So this is going to be the alkyl group. The second word in the name of the ester is going to be obtained by replacing the ic acid of the parent corresponding acid by O8 in both the common name as well as in the IUPAC name, right? So now this part is what we will be getting from the corresponding acid. So the CnH2n plus 1 COOH, that would have been the acid. We have removed the H from here and this becomes the alkanoate. Let me give you some examples. You will be able to understand better. So first let us see when N is 0 and M is 1. Okay. So we have N to be 0. So this becomes H. Then we have a COO and M is 1. So this becomes CH3. Okay. So now this is the methyl group which is attached to the oxygen. This hydrogen is attached to the carbon. So first of all, the first word is going to be methyl. Okay, and now this compound, the remaining that is left after the methyl group, what would have been the acid had this not been an alkyl group? It would have been a hydrogen atom. It would have been a methanoic acid, HCOOH. So now from the methanoic acid, we are removing the ic acid and replacing it by a OH. So this becomes methanoate, methyl methanoate. Okay, and had the common name been, so we would have written this as formic acid. Now it is no more a formic acid. We will be writing this as a methyl formate. Okay, so next we have is a N equal to 1, M equal to 1. So again on both sides we will be having a methyl group over here, but this is the group that you will be writing first. So this is going to be methyl, and now this compound, it has 2 carbon atoms. So this would have been an ethanoic acid. So we will be writing it as ethanoate. Okay, next we have is N equal to 1 and M equal to 2. So this becomes CH3, this M becomes C2H5. So here now this is going to be what group? This is a ethyl group. So this is ethyl ethanoate. Fine. And when N equal to 2 and M equal to 2, we will be having the ethyl group over here. So we have ethyl, and now this has a 3 carbon molecule. So this is going to be, 3 carbon molecule. No, we are talking about the only alkanoate part over here. Okay, so the molecule is having 5 carbon atoms. So this is going to be propanoate, right? So we have ethyl propanoate, and when we are talking about the common names, it is methyl formate, methyl acetate, ethyl acetate, and ethyl propionate. Fine, I hope this is clear. Please do remember this very well, because these are the names which you are going to generally confuse. That is what we have seen for the students doing. Most of you remember, yes, this is an ester, but when you are going to write the name, you get confused which part to write as the alkyl group, which part to consider as the alkanoate group. Fine. The next acid derivatives are the acid anhydrides. So we are going to obtain them from the acids. And how we are going to obtain them from the acids? These are anhydrides. This means essentially wherever you see the word anhydride, there is going to be a loss of water molecule. Now how are we going to lose that water molecule and get the acid anhydride is what you have to learn over here. So what we have is that we will be obtaining these by removing 1 molecule of water from 2 molecules of carboxylic acids. So for example, you have 2 carboxylic acids, CnH2n, COOH, and CmH2m, I have written them in this way because I want to remove 1 water molecule. So let us remove the water molecule, right? So what we have done, from one of the acids we have removed the OH group, from the other acid we have removed the H. It does not matter where you are going to put this, either you remove it, the OH group from here and the H from here, it is going to make no difference at all. Okay. So this is how we are going to obtain it, removing one water molecule from two molecules of the carboxylic acid. So the general formula for the compound is going to be CnH2n plus 1, CnH2n plus 1. Then we had a CO over here, a CO over here, a oxygen, a CO, CmH2n plus 1. So this becomes the general formula for the compound. Easy enough, I hope. So the functional group is going to be a C double bonded to oxygen, then an oxygen atom, a C and a double bonded to oxygen. So I hope this you can understand over here as well, that how you're going to get the functional group of the compound. So the IUPAC names are derived by replacing the word acid by anhydride in the name of the parent acid from which the acid anhydride is obtained. So let us see the examples over here. When N is 1 and M is 1. So the parent acids, they were the ethanoic acid, right? So what we get over here is going to be a CH3COO, CH3CO. Okay, so this is how you have got this, and we call this as the ethanoic anhydride, the common name being acetic anhydride. And when N is equal to 2 and M is equal to 2, so the acid was propanoic acid. So what you will be getting, the compound will be called as the propanoic anhydride or the propionic anhydride. Now the N and M, they can be different as well, and when they are different, then you will have to name them from the both acids that you have derived the anhydride from. So this you can see over here, this acid, what is it being derived from, is going to be CH3COH. So this was ethanoic acid, and this acid, it would have been CH3CH2COH, it would have been propanoic acid. So the anhydride we obtain is going to be called as ethanoic propanoic anhydride. Okay, so you will have to write the name of both the acids, and the common name is going to be acetic propionic anhydride. Easy enough, I hope. So that would be all for this lecture. There are still more functional groups and the class of compounds related that we have to still cover, and that we would be doing in the next lecture. So I hope you are looking forward to understanding more things quite in detail. You are understanding everything very well. So please do subscribe to the channel if you have not done till now, because here you are getting all the detailed lectures for your courses, and I hope you will be able to excel your examinations with all this learning. So do subscribe to the channel, click on the bell icon. Any doubts, most welcome, put them in the mail section, h2chemistry@gmail.com. Put that in the comment box, or you can join us on the Facebook page of the channel by the same name, H2Chemistry. So see you again. Have a nice day. God bless you.